All right, so in this video, we're just going to look at a couple of smaller examples of some chain rules being applied to trig functions. The reason why I think it's important to look at some of these simpler cases before we get into a more complicated one is because of the notation of where the exponent is inside the trig function itself. So remember, in this first example, this kind of says the same thing, even though we would never write it as sine of x all raised to the fifth. So if we view it like that, then our y prime would be the 5 being multiplied down, keep the inside the same, and subtract 1, back times the derivative of the inside, which is cosine of x. Okay, so we've got the 5 coming down, leave the inside the same, subtract 1, back times the derivative of the inside, which is cosine. Now again, we don't really write things like this, and I don't want you to be doing that. The same thing here, I don't want you to write it like this. If you choose to do so as an intermediate step, that's fine, but I need to see a final answer of 5 sine to the fourth x cosine x, the way it should be written. So there's the example of that first one. Now for the second one, this one's actually probably a little easier because of the 5 is attached to the inside portion of the function. So we would start by simply derivative of the outside. The outside would be sine, so we would have a cosine, keep the inside the same, back times the derivative of the inside, which is 5x to the fourth. Okay, so the outside portion in that second example was the sine function itself. And then for this third one, this is one that will be easy for you in a couple days. But for now, the first time you see it, it's one of those things you'll probably question from time to time. To convince you of what the answer is, I'm going to go ahead and actually treat this as a product. Okay, so we'll call that the first. We'll call that the second. So when I take the derivative using the product rule, the derivative of the first is 0 times the second, and then plus derivative of the second, which is cosine, back times the first. So when all is said and done here, this goes away and we have 5 cosine x. So what I'm trying to get at here is whenever you have a constant multiplied by a trig function like this, it's not a chain rule. It's not even technically a, well, I guess technically it's a product rule. But when you see something like this, it's simply going to be the derivative of the part that's got the variable in it attached to that 5 or constant out in front. You don't have to show me this every time. I want you to get to a point where you can see this and go straight to this guy right here. All right, so for our last example, we'll take a look at this guy here, and you can see it's going to have some chain rules involved in it as well. So y prime. So we're going to start here on the outside, and from the outside we know it's going to be this guy. We're going to bring the 4 down, we're going to keep everything the same, and we're going to subtract 1. So that's going to give us a 4 cosine to the third of secant squared of 3t back times the derivative of the inside. Well, that inside now is going to be the cosine function, right? The 4 that I showed you in the last example, how I wrote it unnecessarily out here, I brought it down. Now the inside is going to start with this cosine. So the derivative of the cosine is going to be the negative sine, keep the inside the same, and now times the derivative of the inside. And by the derivative of that inside, I'm talking about this guy. So the 2 will come down, we'll subtract 1. So the 2 will come down. We'll have a secant now to the first of 3t, back times the derivative of its inside, which was the secant function. So now we'll have secant of 3t, tangent of 3t for that derivative. So we'll have a secant of 3t, tangent of 3t, and then finally the derivative of its inside, which would be just a 3. So a huge product here because it looks like we have 3 different chain rules. So I'll kind of walk through it again slowly and hopefully you could follow. So for the first one, the 4 comes down, everything on the inside stays the same, and we subtracted 1 into that 3. Then for the derivative of its inside, derivative of cosine is negative sine, keep the inside the same. Then we have the derivative of its inside, which would be this guy, needing to multiply the 2 down, keep the inside the same, subtract 1, followed by the derivative of the secant, which would be the secant 3t tangent 3t, followed by the derivative of the inside, which would be 3. So I guess that'd probably be 4 different chain rules if I'm counting correctly. But either way, take a minute and kind of, if you need to spread that apart and write it differently to help you understand it, by all means, feel free to do so. But this is a good example of how messy these things can get, even though the rules themselves aren't difficult to follow. At this point now, then you could clean it up and simplify it, of course. But right now, we're just focusing on the unsimplified derivative for now.